Hi, third graders. All right, hey, check it out. So now I have figured out a better system for teaching the math portion. Yay! So today we're going to work on problem set 13. And what we're going to be doing is really looking at perimeter again. And this time, though, what's nice is they have given us all the measurements of the figures. And we're really going to be focusing on how to kind of keep track of calculating perimeter. And also, I'm going to throw in a little bit of some of our geometry vocabulary because it's such an essential piece of this module. So to find the perimeter of this shape, the first thing you'll notice is that it is four-sided. So do you remember what you call a four-sided figure? Yep, a quadrilateral. Now this quadrilateral also is known as a rectangle, right? Because it has two sets of sides that have congruent lines. They also run parallel to one another. So that also gives it the classification of a parallelogram. Now, this is almost a regular polygon because it has four right angles in it, but it does not have four equal sides. So therefore, it is not a regular polygon. It's just a rectangle. Okay, so when we are calculating perimeter, remember that is when we're going around the outer edge of the figure and we are not calculating all this area on the inside. So they have already listed these off, but I'm going to just kind of model our checking strategy of moving around a figure and recording those side lengths. So they're all there. So now I just have to add them up, and we're going to talk about some strategies to adding up perimeters as well. So we're going to use kind of like a algebra format, simplify as you go style. And if we go 8 plus 3, that gives us 11. I'm going to write kind of tiny in here. I pull down my operation because I'm still going to need to do that to whatever is on this side, which is another 8 plus 3. So I have an 11 plus an 11, which gives me 22 inches. Okay, so that is the calculated perimeter of the figure. If we go on to B, one of the things you'll notice is that this is also a quadrilateral, right? This is a special quadrilateral though, because all sides are of equal length, which makes it a square. So this square also can be classified as a parallelogram because it has two sets of equal sides. It actually is classified as a regular polygon because all sides are equal as well as every angle inside of it. It is also, favorite test question, classified as a rectangle because it does have two sets of parallel sides. And each side set is of equal length, just like over there. All right, so we have 4 fours. So I'm going to check them off as I go. And you'll notice on this one that this is repeated addition of 4s, right? So the other mathematical strategy we could use in our mind is to multiply 4 times 4 to represent that and get 16. However, just like I spoke to you about in problem set 12, I really want you to keep separate filing systems for perimeter and area. And the best way really to do that is to use addition for perimeter right now and use multiplication for area. So I'm just going to model if we were using addition. I know it's not the fastest in this case, but 8 plus 8 is 16. Now, what we'll learn about squares as we kind of go is they're unique shapes because their area, right? If we were to calculate this area, which is a 4 times a 4, we'd get 16. And if we add up all 4 sides, we also get 16. So squares are unique in that their area is actually equal to their perimeter. That is not very common of other polygons. Okay. Continuing on, we have a triangle here, right? So this triangle has 3 different side lengths, which actually classifies it as an isosceles triangle. So if you're asked to draw an isosceles triangle, that means you're going to need all different side lengths of your triangle. Now, this side is 6, so I'm going to write 6, and I'm going to check it off as I go. You do not want to leave off a side length. And as we go through this module, you will see that our figures are going to get fancier and more complex. Some side lengths are going to be missing eventually, and so it's really important that you build good habits around this. So 6 plus 11 is 17, right? We're going to pull down our operation of addition and add on this 9. 17 plus 9. So when I'm mentally thinking about this addition, right, 17 is 3 away from 20, which would leave me 6 more on the other side. So this will be 26 centimeters. Now you'll also notice that we're not putting any square units on any of these measurements because we are not laying over a grid on these figures measuring in squares, right? We are just measuring the length of these lines. The next figure here, can you recognize what this one is? This one is a trapezoid. So this trapezoid has one set of parallel lines. It really doesn't matter if their side lengths are equal or not. It is classified as a quadrilateral as well. So let's figure out what its perimeter is. We have 5 meters, 9 meters. And so I pick one spot and then I kind of work my way around from there. And looking at this, I could kind of mentally strategize 15 plus 5 and get 20, but I think for the sake of today's lesson, let's just kind of continue down with this pulling down and simplifying strategy. 5 plus 9 is 14, right? Don't forget to pull down the operation. 15 and 7. Well, 15 is 5 away from 20, right? So that would be 20 plus the 2 left over would give me 22. And I can sense here that I'm probably not going to have any regrouping, but I'm going to go ahead and stack them just to make sure that my math stays accurate. So I've got 36 meters. When I continue on, here we have a more unusual shape, right? It's kind of this like flag or, arrow. This figure has 1, 2, 3, 4, 5 sides. So even though it doesn't look like a classic pentagon, it is because it's a 5-sided figure. It does actually have one set of parallel sides here. And let's go ahead and calculate around here. So I'm going to start at the 9, 9. Check the 2, 2. Check the other 2, 2. Check the other 9, 9, and check the 3, and I get 3. And when I go to add these up, this one's kind of set up nice because I get an 11 here plus my 11 here. Now, a little error that sometimes I do see is that I've seen students then pull this 9 together with this 3. So be careful of that. This 9 is already been added to this 2, so it's no longer available. This 3, you can't forget about it though. You got to pull it down. Okay. And then we have 11 plus 11, which we can mentally do, right? 22 plus 3 makes 25. All right. Looking good so far. Moving on. Here we have Alan's rectangular swimming pool is 10 meters long and 16 meters wide. What is the perimeter? So here we can see, and I'm going to model a little bit of organization with parenthesis work because I know that's something that most of us are comfortable with. I am going to go ahead and list it going around, but then I am also going to show you a little peek at the formula for perimeter when you're working with a quadrilateral such as this one. So then I have a 10, and here I'm clustering, right? Because I would add these 2 first, add these 2 second, and come up with my perimeter, right? Let's even throw in a variable there, might as well. So our perimeter here would be 26 plus 26 equals P. 26 and 26, yep, I can feel that regrouping. So I'm going to go ahead and add these up, and I get 52. So the perimeter is 52 meters. Now, the formula for perimeter when you're working with a quadrilateral is, it looks like this: 2 times L plus 2 times W. Okay, looking really fancy there, right? We got multiple variables in there, but basically it just means you can double the length and add it to double the width. So if we were looking at this, right, and this, I'm not expecting this, but if you're looking for a little extension, this would be an option to kind of play around with when, again, you're working with a quadrilateral. So we could potentially reorganize this where we have 2 times the length, right? We've got 2 16s. So I would say 2 times 16 plus 2 times my width, which is 10. And you can see it's the same situation, just reorganized. So we have 2 times 16, which is 32, plus 2 times 10, which is 20. And our perimeter, again, would still equal 52 meters. Okay, this part here, that's just a little bonus exposure if you're interested. Now, down on number 3, we have this mountain rangey figure, right? So here's one of the more fancy looking polygons that we're going to see today. So you just have to really make sure, again, keep that system of moving around the figure while you're recording your side lengths. So we have a 4, and we have a 2, and I have a 3. Then moving on, I have a 6, and then I have a 9. All right, so here I'm going to go ahead and pull these down, right? So I have a 6 plus, if I do these two, I have 9. And again, I can't connect these two because the 6 has already been joined, but I can pull down this 9. Don't forget to pull down the 9. Continuing on with this simplification of the problem, we have 6 plus 9 equals 15, plus 9 more equals 24 inches. Now, our last 2 problems ask us, what's the perimeter of the shape? Well, we already calculated that. So there we go. Lila says the shape is a pentagon. Is she correct? Why or why not? Well, let's count up these side lengths. We have 1, 2, 3, 4, 5 side lengths. And if you think about a pentagon, right, penta is going to mean 5. So she is absolutely correct because it has 5 sides and it's a closed figure. So therefore it's met the criteria. All right, so yes, it is a pentagon because it has 5 sides and is a closed figure. All right, so that's our lesson for today. Don't forget, you can always pause these as we go, take your time, do them, check them, use them however you want. I'd like you to complete the homework as your independent assignment, and then you can upload it to Seesaw so I can take a look at how it's going. All right, see you next time.